All right, folks. Welcome back. It's me, Mr. Morad. Going to give you another quick review video. Hopefully, this is kind of getting old. You already know what all this stuff means on the periodic table, but I'm going to go over it with you anyways until I can come back to school and I'm cleared to go back. I am going to do this for you guys because naming it's kind of a tricky thing. So, you should have some type of periodic table already in your possession that shows you the charges when the metals get oxidized and when the non-metals get reduced. Okay, it's going to help you in bonding. It's going to help you quite a bit. All right. So if you're looking at these little deals on these little magnets here, you should already know the alkaline metals are the very first group. And they're a +1 charge, right? So all of these, if you do the Lewis dot, they all have just one little dot. They all have the exact same Lewis dot structure, okay? So there's my alkali metals. And then right next to those that got a +2 charge is your alkali earth metals. And boom, they go right there. Alkali metals are really reactive, and then second to that would be alkali metals in terms of going from left to right, and they're reactive for different reasons than the halogens on this side. Okay, and hopefully you know that these are the transition metals in the middle. I've highlighted a few that only have the reason why they're transition metals is because they will have different charges. Okay, they'll oxidize differently. Okay, so there are a few in here that we highlight that are always going to be 1 charge. So even though they're sitting in this area where the transition metals live, they'll only have 1 charge. Okay, and so you don't have to worry about the naming scheme in terms of writing Roman numerals. And once you get through these notes today, hopefully that'll make a little bit more sense. But scandium is always +3, zinc is +2. Cadmium is +2 and silver is +1. Yes, there's more in here that will just have 1 charge, but we don't really mess around with those too much, not at this level. Okay, so these are the ones that you kind of need to watch out for. All right, and then of course you have your nice little dividing line between the metals and the non-metals, but in between those is the metalloids, and I've got those highlighted here in orange. Okay, these will act a little bit differently. But if you look closely, boron, you can see the 3 little dots there. That's how many electrons it has in its valence shell. But really, aluminum is kind of the metal that's always going to be a metal, and it's always going to be a +3 charge. And we use this one a lot because of that +3 charge. Okay, and then carbon group. You've got carbon here, you've got some metalloids, and then you've got some metals down here that act like transition metals. So these are the exceptions to where they sit on the periodic table. And I just highlighted tin and lead. Both of those can be +2 or +4. Okay, but there's other ones that do that. Antimony will have a +3 or +5 charge. Bismuth, same thing, +3, +5. Polonium and thallium will also have different valences, but mainly we use tin and lead. These other ones might pop up. Just know that you'll know it by the name, hopefully, after you get through this. Okay, and then as you go across, now you're going to start to get into the non-metals for real, and nitrogen is one with its 5 little dots, right, with its Lewis structure, unreacted at this point. But all of these will have up to here will have a -3 charge. Okay, oxygen, sulfur, and selenium, they will have a -2 charge. Okay, when they get reduced, right? Because non-metals get reduced when they take on more electrons to fill in that octet, right? That's why we use Lewis dots. And then of course halogens right here, it's got 7 electrons in their valence shell. All of them do. Okay, they only need 1 electron, so that's why they're very reactive, extremely electronegative, fluorine being the most electronegative. All of those will just take on 1 electron and they'll have a charge of -1. So halogens go right here. And then the noble gases is the last part right here. And all the noble gases have a charge of 0. They're inert, right? They don't react because they've got a full octet already. The only noble gas that doesn't have a full octet is, of course, helium, because it only needs 2, filling that 1s orbital. And of course, our transition metals go in the middle. So hopefully that was familiar to you. You've seen this enough to where you can be like, all right, because you won't believe how much you're going to refer to that just looking at the charges, right? When you're trying to figure out how to write a formula, or how many metals, or how many of this metal goes with this non-metal, so on and so forth. It's based on the charges. Remember, in an ionic compound, which we've talked about, you have a metal combining with a non-metal, okay? And then we're going to talk about polyatomic ions, which is the next thing that you're going to have to know how to use is polyatomic ions, and that's what we're going to cover today. And remember, it's still an ionic compound. If you have a metal with a polyatomic ion, it's still ionic, okay? And so if you flip your periodic tables over, it's actually going to be this periodic table, okay? You will see the polyatomic ions on the back that you're going to need to know, and you're going to need to memorize these. So, write them down, do a Quizlet, and just kind of sift through them and test each other out, because when it comes time for the test or a quiz, when we do naming, and if I'm there, when you flip this periodic table over, it's going to be blank. There's not going to be anything back here. So it's up to you to study that. How many times do you need to go over these to figure out, that nitrite is NO2 minus 1? I don't know. Nobody knows but you, right? It's different for everybody. So you got to practice that and get yourself ready, because naming, like I said, it can throw some folks off just because there's a bunch of little rules, right? And so far, we've just been talking about ionic compounds. So we're going to introduce you to polyatomic ions and ionic salts in today's notes. But I just wanted to throw this back at you just to, hopefully you saw it once before and you're going to see it again. And, I'm super excited to see you guys succeed on this upcoming test for naming, because, we're always pulling for you guys to do good. And oxalate, don't forget to put oxalate down. It's C2O42 minus, okay? We're adding that in there, okay? Whether you're with Compton, Keith, even with Mrs. Stranmo or Mrs. Paris or myself, you're going to have to use these polyatomics in naming, okay? So hopefully this helps. Give a shout out to yourself if you got these, if you understood what was going on the periodic table, and this is kind of old news for you, then, pat yourself on the back, because you're going to be using this a lot when you make compounds, whether they're ionic or if you're using covalently bonded structures, which we'll talk about a little bit later, because there's a little more to those. But all right, so hopefully this helps.